Fredholm equation of the first kind. Fredholm equation of equation of first kind. First kind. Fredholm equation of first kind. F of x equal to integration a to b kx comma t phi of t dt phi of t dt. Second, Fredholm equation of the second kind. Fredholm equation of second kind. Second kind. Phi of x equal to phi of x. F of x plus lambda none of other people. Of x plus lambda integration a to b kx comma t pi of t pi of t dt. Fredholm equation of second kind. Third one. Volterra equation of the first kind. Equation of Volterra equation of first kind. F of x equal to integration a to b k into x comma t pi of t dt of t dt. dt. So Volterra equation of second kind. Volterra the equation of second kind. Volterra equation of second kind. Phi of x equal to f of x plus a to b kx comma t a to b kx comma t phi of t dt in all four cases phi of t is unknown function in all four cases phi of t is unknown function where kx comma t we call kernel where k unknown function kernel x comma t kx comma t is called kernel kernel of f of x kernel of f of x are unknown f of x are unknown kernel and f of x unknown 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 when f equal to 0 when f equal to 0 equal to 0 the equations are called homogeneous when f equal to 0 then the equations are called homogeneous equations. Homogeneous. Homo means homogeneous equation. Okay, next. Form the integral equation corresponding to differential equation and the initial conditions. Homework. Theorem. Volterra equations. Short answer. SAQ means short answer question one. Okay, then form a integral equation. Form a IE means integral equation corresponding to the differential equation corresponding to the differential equation. DE means differential equation. Y double dash X Y dash X Y dash plus Y equal to 0. Y equal to 0. And the initial conditions. Initial conditions. Initial conditions. initial conditions. Y of 0 equal to 1. Y dash of 0 equal to 0. Y dash of 0 equal to 0. Solution. So d square y by put d square y by dx square equal to pi of x. Then dy by dx dy by integration 0 to x. Integration 0 to x. Pi of x. Pi of t dt. Dt plus y dash of 0. Y dash of 0 is given 0. That equal to, because y dash of 0 is given 0. That means integration 0 to x pi of t dt. Since y dash of 0 equal to 0. Y dash of 0 equal to 0. So consider equation number 1. Hence y equal to integration 0 to u. Integration 0 to u. Integration 0 to x pi of t dt. Pi of t dt du, which on integration by parts, integration by parts, and by parts. By parts. Integration by parts gives y equal to integration 0 to x minus u, pi of u du plus 1. That equal to integration 0 to x minus t, pi of t dt, pi of t dt plus 1. Equation number 2. Substituting 1 and 2 into the given differential equation from equation number 1 and 2, we obtain we obtain we obtain we obtain differential equation. We get phi of x equal to phi of x plus integration 0 to x phi of t dt phi of t dt plus 0x x minus t phi of t dt plus 1 equal to 3, or phi of x phi of x phi of x equal to minus 1 minus 0 to x 2x minus 2x minus e phi of t dt phi of t dt. Unknown function. It is the variable. This is the kernel of f of x. F of x is unknown function. From 1 and 2. 1 is the dy by dx. Dy by dx. Dx minus t pi of t dt plus 1. What is this y? So pi of x, pi of t dt, x minus t, x minus a pi of t dt plus 1. Minus t pi of t dt plus 1. Pi of x equal to pi of t. Then next theorem, page number 214. So, Fredholm, Volterra equations, theorem, theorem. 7.3.1, 11.3.1, Volterra equations. What are equations? Home. Solve the integral equation. क्या करने का है? SCQ. Solve the integral equation. Integral equation. Solve the integral equation. Phi of x equal to 1 plus 0 to x, 0 to x, phi of t dt. So that's the problem. Solution. In this question, kernel of kx comma t means kernel of x comma t. equal to 1. Comma equal to 1. And f of x equal to 1. f of x equal to 1. And lambda equal to plus 1. Lambda equal to plus 1. So pi naught equal to pi naught equal to f equal to 1. Pi 1 x pi 1 x equal to 0 to x 0 to x kx comma t kx comma t pi of pi naught 0 t dt that equal to 0 to x this equal to 1 pi naught t pi naught 0 is this is also 1. So pi naught 0 to x dt that equal to x minus 0 is x. So pi 2 of x equal to integration 0 to x kernel x comma t pi 1 of t pi 1 of t dt. So already kernel of x comma t equal to 1 pi 1 of t pi 1 of t is x pi 1 of t pi 1 of x equal to x means pi 1 of t is t that equal to integration 0 to x x dt that is x square by integration x is x square by 2 x square by 2 right x square by 2 x square by 2 right. Similarly pi 3 of x can be written as integration 0 to x kx comma r comma t k not r x comma t printing mistake x comma t means kernel of t kernel pi 2 of t dt. So x square by 2 this is 1 this is x square by 2 1 by 2 outside integration 0 to x x square dt. That means x square dt is x cube by 3 3 to the 6. So x cube by 6 or 3 factorial. X cube by 6 or 3 factorial. By induction, it is easy to see that by induction, it is easy to see that it is easy to see that It is easy to see that by induction, it is easy to see that by induction, it is easy to see that phi of nx, phi of nx equal to x power n divided by n factorial. This can be written as, that's where they wrote x cubed 3 factorial. Hence, pi of x equal to sigma n equal to 0 to infinity lambda power n pi n x, that equal to n equal to 0 to infinity pi n x, x equal to e power x, equal to e power x. Hence the solution. This completes the solution. Okay. Next. The solution of theorem. Solution of Volterra equations of first kind. Theorem. Discuss one theorem. Is the theorem. Solution of Volterra integral equation of first kind. Solution of Volterra IV means integral equation of first kind. Right. Now let f of x is a continuous differentiable function. Let f of x is CT as continuous differentiable function. Fn means function on a comma b on closed interval a comma b. such that f of a equal to 0 and kernel of x comma t a continuous differentiable function, kernel x comma t continuous differentiable function on a comma b into a comma b, a comma b into a comma b. Then equation f of x f of x on f of x equal to integration a to x comma t phi of t dt. So, admits a unique continuous solution in the interval a comma b dash, a less than b dash less than or equal to b, kx comma t equal to 0 for a less than or equal to x less than or equal to b dash. Also, the solution of the above Volterra equation of the first kind is the same as the unique constant solution of the Volterra equation of the second kind. That means f of x, so f dash x whole divided by kernel of x comma t, kernel that equal to phi of x, plus integration a to x, a to x, a to x, kx x comma t, ax x comma t whole divided by k x comma x, k x comma x, phi of t dt, phi of t dt. That equal double star means second, nothing but second equation. So x comma t denotes the partial derivative of k. Kx denotes the here. Kx denotes partial derivative of k. PD means partial derivative of k with respect to x. With respect to x. So proof. Proof. Phi naught x is continuous solution. Is continuous solution of double star means second equation. If and only if phi dash of x divided by kx comma x that equal to phi naught of x plus a to x kx x comma t kx x comma t whole divided by kx comma x comma x phi naught t dt phi naught t dt. If and only if f dash x f dash x kx comma x phi naught of x, that's integration a to x kx x comma t is kernel. So phi naught t dt t dt. This is nothing but keep 3 star. If and only if and only if integration a to x f of x dx f dash x dx a to x integration k x comma x phi naught of x phi naught of x plus integration a to x kx kx x comma t phi naught t dt phi naught t dt whole dx whole dx. If and only if and only if f of x equal to integration a to x integration d by dx integration a to x kx comma t phi naught of t dt equal to dx. Phi naught of t dt. If and only if using 3 star if and only if and only if f of x equal to integration a to x kx comma t phi naught of t dt. dt. If and only if phi naught of x is a continuous function solution of is continuous solution of star star one. So from Newman series theorem 11.4.1. 11.4.1. Fredholm equations and Newman series. Newman series. Homework. Important for 10 marks. Now we'll discuss one problem. Fredholm equations with separable kernel. 11.5.2. Page number. Page number 223. Example. Some. Solve phi of x. Solve phi of x. Solve phi of x. Equal to x plus 1 by 2 integration minus 1 to 1 superscript level. This thousand will decide. In this notation of the above discussion, that's equal to M1 x equal to x m2x equal to 1, n1 t equal to t, n2 of t equal to 1, n1 of t equal to n2 of t equal to t, lambda equal to 1 by 2, f of x equal to x, b1, b2, a11, Fredholm equations of its separable kernel. Fredholm equation. This question is Fredholm equations of separable kernel. Kernel. Refer this. So what's B1 equal to formula? B1 equal to integration -1 to 1 n1x f of x dx n1x f of x dx equal to integration -1 to 1 minus x dx 1 into x dx that equal to 0. B2 formula integration -1 to 1 n2x f of x f of x dx that equal to integration -1 to 1 x into x dx that equal to 2 by 3. A11 A11 that equal to A1 A1 equal to -1 to A -1 to n1x m1x 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 dx that equal to -1 to 1 x into x dx 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 that equal to 0. A12 that equal to -1 to 1 n1x m2x n1x m2x dx that equal to minus 1 to 1, minus 1 to 1, 1 into 1, 1 into 1, time over. One comma dx equal to 2, comma dx equal to 2, a2 comma 2, a2 comma 2, a2 comma 2, integration minus 1 to 1, n2 n2x into m2x dx, m2x dx, 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 m2x dx. Now this gives 0. So a to 1, a to 1 gives the value n2x integration minus 1 to 1 n2x. No? So m1x dx, m1x dx. So this gives value 2 by 3. So a equal to here. Hence a equal to 0 to 0 to matrix. It forms a matrix 2 by 3 0. Two by 0. 2 by 3 0. 2 by 3 0. So that means 1 minus lambda a, huh? Lambda a, that equal to 1 minus 1 minus 1 by 3 1. Okay, rest you follow this one. And here like example 11 point, example 11.5.3, 11.5.4. Homework most important for 10 marks today or 5 marks. Okay, thank you. Thank you very much.